So let's get started. I mean, I just wanted to ask you, is there anybody here in the audience that does not have a Visa card? All right. Oh, there's one person. Okay, prepaid ones. Oh, all right. How many of you actually use Visa through their mobile phone, through your mobile phone? Oh, not that many. All right, that is quite, okay, fair percentage. Anyway, so the Visa is obviously accounts for a lot of commerce that goes across the world. The mobile offerings in Visa are relatively a new thing. But the point about anything mobile is that it drives up the time scale and thereby the requirements for a data platform. So let me start by saying that last year when we came to HBase Con, Visa had no HBase. Or even if there was any HBase, somebody might have done some kind of a proof of concept. But definitely there was no Visa HBase in production. And already right now, we have a large installation in production. So what I'm going to try and tell you is, what did we do in 1 year? We had to bring HBase into the Visa environment very quickly. And last year, we were looking through for some kind of a presentation like this. If somebody wants to adopt HBase very fast, what would be the right way to do it? And we didn't have any answers. However, we got a lot of suggestions. So we came back this year to give you what happened through this year, trying to get HBase into Visa very, very fast. And remember, Visa is transacting all the time, all around the world. So it's a pretty busy place. And so trying to bring something in production has a lot of requirements. So when I came in, so this is how I can boil down the requirements. Data had to be loaded in real time. Somebody should have to have the ability to go from some kind of a recent transaction all the way to 2 months back. So from any kind of an account number, they should be able to get back their most recent and also 2 months back. And all this writing and reading has to be done in milliseconds. So that was the requirements that was given to us. And people were not necessarily looking into HBase. They're looking into some kind of a NoSQL solution. And so here is sort of a mobile offering. So I'm assuming most of you have done this in some form. But if you haven't done it, you should at least give it a try, which is you take your Visa card, you put it in your mobile phone, and then you pretty much wave your mobile phone when you're purchasing something, and you have your transaction showing up on your mobile phone almost immediately afterward. And you can see the leg where NoSQL is required. There is no other way you could get the kind of performance, speed, and the volume of data that you have to process without having some kind of a NoSQL solution. So basically the thing is we had to build a real-time and a scalable transaction history service. And then we went through some amount of usual debate that happens within a company. What is the right NoSQL solution? And then we chose HBase. And then we immediately migrated our most prominent mobile offerings to this platform. And this is happening right now. If you are actually using any of our mobile offerings in which the Visa card is in there, you're actually using HBase. And that is a pretty big scale. Unfortunately, I cannot give you any numbers about our scale. That's a legal requirement. But you can pretty much understand that it is happening at quite a large scale. So through this talk, I mean, we are assuming some knowledge and familiarity of HBase. But this talk, as I like to say, it's all about the learning events that happened in the course of a year. And hopefully, this will help you understand and maybe avoid some of the pitfalls that we fell in, but hopefully recovered fast enough so that we could move forward. So the first thing that happens is that in any kind of NoSQL selection, people ask is, how should you choose a NoSQL solution? And one of the easy ways to do it is through YCSB, because YCSB can be easily put together. You can run some load. You can try out various NoSQL solutions, and you may say, okay, well, that probably is a good way to make a NoSQL selection. But the answer is actually no. Don't use YCSB unless you know how to configure every NoSQL solution in the most performant manner. Some NoSQL solutions, and Apache HBase just happens to be one of them, has a large number of configuration parameters. And to get them all right and having apple-to-apple comparison of NoSQL solution is not going to happen, especially when you're getting in the game for the first time. So we learned quickly that if you actually used YCSB, we would not be using HBase. We would be using a different solution. Because there are other solutions that out of the box perform much better than HBase does. But however, YCSB is actually a great tool. It's a great tool for checking your configuration changes from a baseline to the next set to the next set. And it allows you to essentially sample. And if people have used HBase, they pretty quickly understand there's a lot of configuration parameters to explore. So YCSB does give you a great tool to actually explore the configuration space if you can narrow down your workload to one of the workload samples that they give in the thing that you download. So another big question that comes up is major compaction. If you have not done HBase, this is going to scare you, because you will hear about write amplification and things like that. And the first thing that you want to ask yourselves is, can we get our first release without major compactions? Should we avoid it altogether? And our answer is, don't try that. You don't have to do it. There are so many ways to get around major compactions even after release. No point trying to do premature optimization around taking out major compactions. This was a big fear on our part. We did a lot of thinking about data design, et cetera, but it wasn't worth our time, finally, now looking back, to have spent that much time trying to figure out how to not do major compactions. One important question that you will run into is, does your problem require transactional support? Now, this is something that we spent some time going back and forth, because the applications that we're migrating, we're actually coming from somewhat of a transactional system. So it was a good question to ask. Is this something that we want to still keep? And we found out that we need secondary indexes. And secondary indexes were a way for us to get at the data that the primary key was pointing to. We loaded the data on a basis of a primary key, but all our applications would actually retrieve the data through secondary indexes. And the question was, what if the secondary update or secondary updates somehow did not complete or ran into problems? And so in each of these use cases where we figured that there may be a problem, we tried to work out the ramifications of finding a transactional solution versus not having one. And by going through each of these use cases, we convinced ourselves that at a row-level transaction was enough. We did not require cross-row transactional support, and we did not have to then worry about transactions. But this is an important thing that people should spend some time through. Building some kind of a cheap transactional support is not hard, but this is a good question to actually spend time on. Then the biggest challenge with a company like Visa, which is quite big, and it has also a big operational support team, and as well as, remember that our development team was very new. We were a few people that knew HBase that came into the company. I've been in the company for 1 year plus a few months. How do you get people learning about HBase, which is quite complex, and without having them put anything out in production? This is a bootstrap problem. In many companies, you'll also face the problem. How do you bring HBase in? Maybe most of the people in this room right now don't have the problem, but I'm pretty sure at least there are a few people that will have that problem. And what we did is we used continuous integration as a continuous learning exercise. So we put together HBase on top of virtual machines, and virtual machines were on VMware were easy to get, and use that to run our application through the process of development. So our folks, the system folks, were actually learning about HBase as people were writing code. So both of them were learning at the same time. And that also helped us figure out a lot of problems, and also at least gave us confidence that when we went into production, we would not feel like we don't have enough knowledge, enough hands-on knowledge. And then the bigger problem then that came about is, okay, you can get the dev team ready using using a continuous integration and agile methodology going. How do you get the operations team to be ready? And if people have worked with operations team, they are not the easiest people to turn around and have them adopt new technologies. So what we did is we actually got into the DevOps model for real. We had developers, and we allocated one developer 1 day a week to monitor production problems. Now, first of all, remember that we didn't go into production right away. There was a production system. We went in shadow mode as quickly as we could get into into our data center. The important thing being is having production load go through our cluster and having the operational team actually be led by the developer, and we shuttle between our Foster City office and our Bangalore office on a 24/7 basis. And the developers were learning about the platforms, and we were creating run books at the same time, and we were also being exposed to the real production load. All right, so getting into our architecture. So remember, this was HBase coming into the company that is running some major production. I mean, it's the whole commerce of the world. Should not say whole. A lot of the commerce of the world runs in Visa. If they start into a problem, they get into a problem, that problem is pretty big. So one of the thing that we had to come up with is how do we read and write data? Because the HBase obviously was as we took it from the Cloudera version that was available, but how do we create simple systems to ingest data and read data? And the simple system meant, though everybody would say, the data comes in a streaming manner to us, that use Apache Spark or use Kafka to load the data. We did not do it. We actually used a micro-batch system. And a micro-batch system, the reason it is good is that we have small little files. We had 250 millisecond files, and that data existed in that file until the data got loaded. And if there was a loading problem, we would retry those files until the data got loaded correctly. And we also had to have a notification system. Every time data comes in, we have to find out, are any of this data that just came in requires somebody with a mobile phone be notified that this data is now here. And so we also created a notification ETL micro-batch system with the master worker framework, where the master kind of tried to see how much workload was coming in, and thereby would allocate more workers, a less number of workers, and thereby this whole system. And also the system, obviously, we went through lots of growing pains, and as we had a problem, we would make sure that the data got retried. Then again, the reading, we used a simple web server. I mean, we used a Tomcat server. We didn't try to actually use more fancy web servers that we actually use in other applications. One of the problems that we found right away is moving from our existing infrastructure to the new infrastructure, everything has to be ready for high throughput. And one of the things that we do, because we are a company that exists in the financial space, we have to monitor more or less every event going through our system. So our audit requirements are pretty important. And so the way we do audit is we look through our events by publishing them into a message queue and writing it to an audit database. Now that part was a bottleneck, we found out, to scaling up the web servers. So we are obviously moving the MQ Audit DB to a big data solution right now. But other than that, the simplicity of this web servers was very easy to debug problems as they happen. Can we ask questions at the end? The availability, again, HBase do go up and down. We also pulled HBase up and down. So we ran 2 HBase in 2 data centers, and the 2 data centers had identical streams of data. So the way our data centers work is some of the streams come through one data center natively, and some other streams come to other data streams natively. And we cross-replicate them, so each data center get all the streams. And then when one HBase is down, we try to shadow all the tables in that HBase in the actual working HBase. And because the transactions keep coming, and when the HBase that went down came back up, we drain those shadow tables until both the HBases are running again, and then we open it up for business. So both these HBases are identical in every respect, and they were there for high availability. HBase do go up and down for many reasons. Okay, some of the few things that we ran into pretty early on is that HBase is very sensitive to the data center clock. Actually, the HBase master is. And that's for a good reason, because it keeps everything ordered. Now, if your clock develops any kind of skew, unless you are very sure that that skew was not going to affect it, the HBase will be brought down. The master will, working with the zookeeper, will not withstand many minutes of clock skew. And especially because we use Kerberos in our cluster, Kerberos does not also survive more than 5 minutes of clock skew. So we had a few times when clock skews was actually affecting our clusters. Our data payload was not sensitive to clock skew, because we were actually ordering by our web servers as well as through the writers. We're already ordering them to their own timestamp, but still something that we actually learned the hard way, that a little bit of clock skew might actually bring your data center, your HBase, pretty fast if you don't worry about it. All right. Okay, at this point, I'd love to give it to CW to take us to the end of this talk.
Hi, thank you, Partha. Hi, I'm CW Chung with Visa, and I'd like to think of this adoption of HBase as a journey. And it turns out we have to spend considerable time in some of the stops along the way, and those stops feels more like a longer trails. And in one of the cases is the handling of retries and exceptions. So if you look at actually the default setting of HBase, the timeout setting is 1 minute, and number of retries 35. And in the case of actually, you also need to do a pause before you retry. And if you multiply them together, this is really takes tens of minutes to time out. So this is one of the first things we actually run into. And the engineers come back saying that, well, how come it actually takes so long to time out? And then we do the investigation. So, and we also run into the problems by the zookeeper on the top of that. So, and in taking up, actually, I recommend a highly readable blog by Lars. And in setting the right retry strategy, we use a fail fast, so that actually we have each of the transaction takes 2 to 4 HBase operations, and we have about a budget of 10 seconds to deal with. So we set the setting to be 1 second timeout and 2 retry in the beginning. And then it turns out it's okay, but we actually run into a lot of IOExceptions during the day. So we actually tune it to 3 times, 3 retries in 1 second, and turns out that actually works reasonably well. But once in a while, we still have actually problems, IO exception. So, and once you have the IO exception, you always ask, is it on the server, the network, or your client itself? The server can be doing something like compaction, flush, garbage collection. The network can have actually busy networks, or even the client. Client can do the garbage collection itself, as well as actually we run some clients on the virtual machines. So those virtual machines may also be not immediately responsive. So in this case, what do we do? So first thing actually we need to do is actually turn on some of the debugging facilities here. These are very helpful debugging. So on the client and the IPC, turn on the debug, you will have a lot more information to deal with. And then when there's exception, catch the exception. The most important thing is really print out the specific region server that is having the problem. And once you actually get the region server, then you can go to the region server log to find out the cause. In many cases, this actually can tell you the problems right away. But what if not? This becomes a detective kind of actual story here. So in order to actually get to a total view of the system, we actually have to build a software tool to collect all the logs here and do some analysis ourselves to extract the information so that we have the total view of what's happening. Now think of that, actually HBase live on the top of HDFS. So you actually have the HBase master, the region server, and then you have the data node, name node, plus the zookeeper, the logs and garbage collection logs to work with. And in addition, we also pull down the events from Cloudera managers. It's a very useful API that you can pull out and get the significant event. Then there are other actually logs that we also look at. The KDC, we didn't have it in the beginning, but turns out actually we run into a lot of Kerberos issues. So the KDC logs become also important for us to analyze what is going on. For the Kerberos, we built a canary so that actually we poke the KDC every twice a minute. And then we also build our own network latency monitoring. So the first version was written in Java, but obviously Java is not the best for this type of latency. So we rewrite it in C to monitor the latency between the client and get the round trip information on a real-time basis. So together with all this type of logs, we actually get into a software the tools to pass the logs. Some of them are single line, some of them are multi-line, XML, JSON, and then we'll normalize the date and time. And then the output is actually and a big CSV file sorted by time and sorted by the nodes. So this way, then you can actually do your own filtering, grab or whatever, it's a Hadoop tool as well. So this actually helps us actually a lot in whenever we have IO exceptions, we actually run these tools, come back within a minute, and then we can actually find out what's going on. Now that is actually the best case. Mostly we can find out the root cause of the problem. But still, sometimes actually we just don't know. It's almost like a detective story you find in the case of a murder. You would like to be able to find the murderer, but okay. Sometimes actually it's really the final and the process of elimination of problems, of factors. The next trail that we spend a lot of time is the Kerberos. Okay. How many of you are running without Kerberos today? Okay, good for you. Because the Kerberos actually has been a sort of actually headache for us. And actually, it turns out I always felt that Kerberos is a subject that warrants a session by itself. And sure, there's an extra section next door. And first of all, we actually use some principle is use fully qualified name, use TCP rather than the UDP. The less obvious thing is actually use configure to start up multiple processes in the KDC. This is MIT KDC on Linux we're talking about. You give a -w option, you can actually specify the number of instances. What does it do? It's actually able to handle a burst traffic better. We see that there's a difference here, okay? And we also set up a backup KDC. And then there's a couple of debugging tips you can use. And also there's some good resources on the web that you can actually look up. So, and right now what we are actually getting into is the issue is around the time that the TGT is renewing. We actually still see some sort of exceptions here. Now, for just a refresh, after you key init, the application principal get a Kerberos TGT ticket from your RAM, and then the TGT is good for 10 hours. Now, for running application, obviously 10 hours is not enough, so you need to renew it. So during that renewal process, this is where actually we observe some kind of exceptions. Initially, we actually use a separate process to do the kinit to get the TGT, but that is not the recommended way because actually this lives in the disk cache versus your in-memory. So there's always a cache coherence problem. So we actually use on recommendation is use the UGI API, user group information, log in the user from key tab. So this does not require a separate process to do the renewal, which is good. And actually, both the class, Hadoop class and also the servers are using that strategy. So they automatically catch the exception and launch the relogin from a key tab. But we did actually still see about 2 to 3 seconds of unavailability from time to time. So if anybody knows the answer to that, I'll be happy to talk to you. And we're also actually considering spawning a thread to do the check TGT and relog in anyhow. These are still ongoing, okay? But the number of IOExceptions due to this is much, much reduced by now. Then there's also another thing, it's called referral ticket. We actually set up a realm trusting another realm. So when we run into a default realm, we are under the impression that once we get the TGT, everything actually is working with our own realm. But turns out it's not. Turns out actually, anytime you actually need to get a service ticket, you still need to go back to your trusted realm to get a referral ticket before you actually get to the service ticket. So that actually really end up adding quite a bit of actually loading on the KDC itself. So that is actually still ongoing. I'd like to actually touch upon the garbage collection quickly here. And indeed, actually, thanks to the sessions last year here, and we were able to actually get, turns out this actually, we didn't spend too much time in it. We just actually read the paper and do it accordingly. So things actually works pretty much out of the box with an appropriate setting. We set the target to 100 milliseconds and YoungGen to 1 gigabyte. And the observation is actually pretty consistent with the published result. 100 milliseconds is 2/3 of the time. 99.98 percentile is 400 milliseconds. But one thing that actually I'd like to, is to show is actually this is our production cluster. This is our experimental cluster when we run the performance. So you can see the shape is a little bit different. So the lesson here is actually, you always actually, do your tuning over there because actually this is how you actually inject different loads. But in reality, you also want to make sure that you actually monitor your production cluster's behavior. And in particular, I think one of the talk by Google this morning is you also want to monitor over long term because things may change. So if you look at these diagrams, both of them actually are able to handle in terms of the SLA pretty well. But if you look at actually the 99.99 percentile, it's actually not too bad, okay? But you also look at the other way is this is 1 over 10,000 times that this will be more than 600 and 700 milliseconds. That tells you that actually your application need to deal with when once in the blue moon, those actually garbage collection does take hundreds of milliseconds. okay? And the good news is actually, in general, 4 times of the target, we were able to get to 99.98 percentile. Okay, so that is actually pretty much it for this for the lessons. And in conclusion, so what we want to do is, I'm going to pass back.
All right, so I think we're trying to sum up here that if there is anybody here who is contemplating using of HBase, try and learn from the previous adoption successes. As CW mentioned, our G1 learning was 0. We pretty much took what we learned from last HBase Con. A lot of the HBase Con, especially this track, is very informative on how to actually create the right sort of solutions. The other thing that we learned is make one major technology change at a time. There is always this thing about the Hadoop ecosystem, and people try to run into the whole ecosystem. It's not a good idea, especially if you're going to be running lots of production jobs and where SLA is important and your sleep at night is important as well. Setting up appropriate expectation that it's a learning voyage, and it's a journey. HBase changes, yeah, there is no such thing as an HBase expert is an important thing. I think we created those expectations early, and I think we did the right thing. Again, going into production scenario with HBase early as shadow and really learning from the actual production load was also very helpful for us. We did frequent releases. I think I don't have to tell this crowd about that, but the whole CI and agile methodology and frequent releases is extremely helpful. We always made sure we had extra capacity for peak workloads in many ways more than one. That was very helpful. And then CW definitely looked in the source code for many, many problems that they had to debug or do root cause analysis. So very quickly, I want to say that there is a fair amount of people that we actually consulted or got help in all kinds of ways. We put together as many people as we could think of. Putting HBase in production, even though though this was not a new application. This was an application that was running for some time, and anything and everything was already known about it. But even then, migrating to HBase does require a lot of investigation and a lot of people's help. Thank you very much.